The first question is a sound wave has a period of 2.5 times 10 to the negative third seconds. What is its frequency? This is a simple plug and chug kind of equation. We know that period equals 1 over the frequency. Since we're given the period, we need to solve for the frequency, which means multiplying the frequency over and dividing by the period. Frequency equals 1 over the period. Then we just plug it in. F equals 1 over 2.5 times 10 to the negative third seconds equals 400. You'll realize that the units here would be inverse seconds. That is also called a hertz. So we have 400 hertz. The moon travels around the earth 8 times in 218.4 days. What is the period? The period describes how long it takes for an object to make a complete revolution, in this case, an orbital case. So if it takes 218.4 days for it to orbit around the Earth 8 times, then all we need to do is divide 218.4 by 8. And that will get us the time for one complete orbit. And that is 227.3 days. Just like that. Calculate the period of the spring with a force constant of 20 newtons per meter if the mass on the end of the spring is 0.5 kilograms. Now, we have the equation T equals 2 pi square root of m over k. 20 newtons per meter would be your k, and 0.5 would be your mass. Say that you didn't remember this equation or couldn't find it on your equation sheet. Is there other ways to get to it? Yes. There's a few relationships we know. We know that omega equals the square root of k over m. And we also know that omega equals 2 pi frequency. And we know that the frequency equals 1 over the period. If we substitute in for frequency, we found that omega equals 2 pi over the period. And if we multiply the period over there, divide it by omega and put it down there, we'd find that the period would equal 2 pi over omega. And we know that omega equals the square root of k over m. That would flip because it's inverse, and you get square root of m over k times 2 pi. Easy peasy. Now, it's just a matter of plugging numbers in. T equals 2 pi square root of m over k. And if you punch those numbers in your calculator, you should get approximately 0.99 period, so it should be in seconds. Or at least with the units that we used it at the time. Here on my poorly drawn graph, you can see the graph of a wave. First off, what is its amplitude? Now, if you look, it looks like it goes up to a maximum of 2. So the amplitude then would be 2 at the units of meters. Next, it asks us for the period. Now, typically you would just look at, okay, I have a maximum, where's the next maximum, what's the distance between them? We don't have another maximum on this graph. Instead, we have a minimum and a maximum. This creates half of a wave. Now, if we want to find the total period, we'll look at what half the period is. It goes from -3 to 3, so half of the period equals 6, and the units are seconds. Then it's just a matter of multiplying that over and finding that t equals 12 seconds. So the period is 12 seconds. Next, it asks us for the angular frequency. We have an equation relating the angular frequency and the period. That would be that the angular frequency equals 2 pi over the period. So we know the angular, well, we don't know the angular frequency, but we know the period. So then we just go omega equals 2 pi over the period, which is 12 seconds. And that equals pi over 6. And we have 1 over seconds, so that's in hertz. A stretched string with a tension force of 1.2 newtons applied to it has a mass of 0.9 kilograms and length of 3 meters. What is the wave velocity? Now, if you looked on your equation sheets or remember from lecture, the equation for this is V equals the square root of the tension over the mass divided by the length. So it's just a matter of plugging in all of these numbers. So V equals the square root of the force, 1.2, the mass, 0.9, divided by the length, which is 3. This should come out to, with a quick calculation, the square root of 1.2 divided by 0.9 divided by 3. Make sure you plug everything into your calculator with all your parentheses. And you should get 2 meters per second. Just like that. Now, if we want to find the equation of this graph, we have our typical wave equation that we've been using most often in class. Y equals A cosine omega t plus a phase shift. Now, if you look at this graph, it goes through the origin, which means it's actually a sine wave. So instead of doing a phase shift for cosine, we can write it like a sine wave. So you'd have y equals a, which is 2 sine of omega, which we found is pi over 6, times t. Just like that.